already went over what you needed to know in Chapter 4 on Wednesday. Chapter 4, we had our 5 ways of proving triangles congruent. I told you you needed to be able to look at 2 triangles and what was given, decide if they were congruent, back it up with one of the postulates or theorems, and then be able to write the congruency by putting the letters in the correct order. Okay? We already went over that. We also talked about isosceles triangles and understanding the relationships and what happens in an isosceles triangle and how to use that information to find missing pieces. In Chapter 5, we talked about parallelograms. We're going to go over the characteristics of parallelograms real quickly. You need to know those characteristics to be able to find missing measures.
What chapter?
Day 2 review.
What chapter?
This is Chapter 5. Let's start talking about the characteristics of parallelograms. The first thing we know is that both pairs of opposite sides are parallel to each other. Both pairs of opposite sides are also congruent to each other. All right? Knowing that, what do we know about the relationship of consecutive angles? They're not congruent, they're supplements. Parallel lines cut by a transversal, same side, interior angles form supplementary angles. What do we know about opposite sides of a parallelogram? Opposite angles. They're congruent to each other. Okay? Opposite angles. The diagonals of a parallelogram. What do we know about the diagonals of a parallelogram? What do they do to each other?
Bisect each other.
They bisect each other, meaning that we form 2 equal segments here, and we form 2 equal segments here. I need some extra little symbols here.
Good.
Okay?
Gosh almighty.
Are the diagonals of a parallelogram equal to each other?
Not necessarily.
Then you say no. Okay? If all I say is a parallelogram, then no, they are not. All right? These are the characteristics. If you're given measures of sides or measures of pieces of these segments, you need to be able to find the other pieces. All right? We talked about special parallelograms in this chapter.
Special.
We had rectangles, squares, rhombuses. Now, since these are all parallelograms, they all share the characteristics that we already discussed. Both pairs of opposite sides are congruent. Both pairs of opposite sides are equal. And the diagonals bisect each other. All right? Now, in a rectangle, in addition to that, not only do the diagonals bisect each other, they are also equal to each other. So when they bisect each other, they form 4 equal segments. So if you have a picture and you know that it's a rectangle, which, by the way, what are the 4 angles of a rectangle?
Right angle.
They're all right angles. Then you know that the diagonals not only cut each other in half, they're also equal to each other. In a rhombus, this is a special parallelogram because all 4 sides are equal to each other. The diagonals still bisect each other.
Don't they do something crazy too?
They're not equal to each other, though, but they do something.
They bisect the.
No, they make
angles.
perpendicular thingies. Oh, there you go.
They're perpendicular to each other. They're still bisecting each other. They're not equal to each other, but they are perpendicular, forming 4 right angles.
Do they bisect the angles?
What?
No.
Oh, that makes sense. It's not Suarez. So you say now mash all of those two together.
Now a square is a combination of a rectangle and a rhombus.
It's got all that stuff.
So it has all that stuff, exactly. It's got 4 equal sides.
It's like the alpha.
Because it's a parallelogram, its diagonals do again bisect each other. Because it has 4 right angles like a rectangle, the diagonals are equal to each other. And because it's got 4 equal sides like a rhombus, the diagonals create 90-degree angles.
Everything's like equal.
Right.
And the sides parallel.
Yes, because it's a parallelogram.
That's what you have to study, right?
So this equals this equals this equals this. Okay?
Great Scott.
All right, those are the characteristics. It talks about trapezoids, another special quadrilateral. Now let's talk about, real quick, the characteristics of trapezoids. It's got 1 pair of parallel sides. Those 2 sides are called the bases. The other 2 sides are called the legs. I'm sure it's a trapezoid.
It's not isosceles.
It's not isosceles. Man, it's 4 sides.
But a square has 4 sides. You know it's.
But a square has 2 pairs of parallel sides.
Wow.
Trapezoid only has 1. What do we call the line in the middle that connects the midpoints? It's the median.
Parallel.
It is also parallel to the bases. And we had a special way of finding the measure of the median.
Oh my god.
It's half.
Patrick?
It's half of the sum of the
B
top
plus
and
B
bottom.
divided by 2.
It's the
Exactly.
average of this.
We're going to add the 2 bases together.
No, we do.
Divided by
This is because there's 2. What if there were 3?
All right. Shh.
Wait, what are the sides called?
Can't have
What?
an
average.
average.
Legs.
Another bottom.
Y'all need to be
You say
quiet.
even with some correct. You can't have an
Josh,
average.
shut up.
You have the average.
Be quiet. The bases here are 10 and 50. If you're asked to find the measure of the median,
30.
it's 30 because 10 plus 50 is 60 and half of that is 30. I want you to take note. What's the difference between these two?
20.
And what's the difference between these two?
20.
It's always like that. All right? If this was 80, we'd add it together, divide by 2, we get,
45,
all right, what's the difference between 10 and 45?
35,
What's the difference between 45 and 80?
35.
35. Now, how is that helpful to you?
It's not.
It's helpful to you if we say this.
25.
The difference between 5 and 15 is 10, so that means the difference between these two is also 10. And you can check, 5 plus 25 is 30, and 15 is indeed half of that. All right? So finding the median. We talked about isosceles trapezoids and the relationships that exist there, what it means. What it means is that the legs are equal to each other. Something else is equal in isosceles trapezoids. The base angles are congruent,
And the top angles.
which would be the top. Those are also base angles, okay? Now, the consecutive angles on the side from one base to the other base are what still?
Supplementary.
They're still supplementary because it's parallel lines cut by a transversal, okay? The median is still found the same way. Understanding the properties of isosceles trapezoids and how to find missing pieces. If you understand the relationships, then you should be able to set up an equation to decide if this is equal, okay, set it equal. All right? In something else we did in chapter 5. If we have